Alright, so let's deal with this problem here, which is about liveness analysis. This is from GATE 2015, I think. It's a pretty good problem on liveness analysis, and we can go over sort of two approaches that can be used to basically do this, right? So the first one is a very well understood and sort of algorithmic and manual way. It is pretty much never going to fail, provided that you actually look at the question, you look at the arrows, you look at the boxes, you look at everything. Basically, you keep your eyes open. If you keep your eyes open, if you follow the steps, you will basically never get it wrong. The second one is kind of manually tracing, which I'm kind of getting used to. I can kind of show you how the idea works, but you will have to do the work yourself, because it isn't that very clear to me right now. And yeah, I've not spent too much time because unfortunately these kind of questions have only come up in GATE like maybe a couple of times, I think 4 times maximum. So anywho, so what they're basically asking is that they've given the definition, the standard definition for what liveness basically means, which is okay, we don't care. The idea is, now they're asking us the variables which are live both at the statement in basic block 2 and in basic block 3 in the above control flow graph are, and then they have given us 4 options basically. So I think what we can do here is we can go ahead and immediately make certain things, right? So we'll make a table. That's basically what we'll do. So we will make a table. Let's make a column called block, right? So block 1, 2, 3 and 4. Let's have that. I'll just have a line, I guess. Hold on, make a line, there we go. Then so we'll have a block, then we will have what we call use. Oops, just give me a second. Yes, we will have a column called use. Now the idea of use, okay, the idea of use basically is that in a particular block, so if you're looking at this particular block, we basically have to look at the RHS. So all the sort of things that are, all the mathematical functions that are happening, we have to look at those, and we basically say that okay, you look at Q and you say that, so the first expression is P is equal to Q plus R. So what you say is, okay, we will check for the previous statement before this, P is equal to Q plus R, is there any assignment for Q? No. So okay, Q will in fact be in the generation list. R, there is no instruction above this particular, the first instruction, where R is being assigned or anything like that, so therefore R is also in the use list. Amazing. Let's move to the next instruction. Now you'll notice S is equal to P plus Q. Now P was just assigned a value in the previous instruction, therefore P is not in fact in the use list. Okay, Q is still in the RHS, we don't care. Now S again, so U is equal to S into V. Now what happens here is S already is in the sort of LHS, so we cannot basically include it, right? So that's why. And then V is a new variable that has just occurred, so we will in fact put V here, because again, if you notice, V has never occurred in the LHS of the block, so therefore V comes here. That is basically the point. Now if you look at block 2, right, so if you look at block 2, you will notice that there is no instruction before, so basically there is no need to check anything. R and U immediately just end up in the use block or the use column, right? If you go to block 3 now, and if you go to block 3, you will see Q is equal to S into U. So again, S and U basically end up in the use column. And if you go to block 4, you will find that V and R basically are in the RHS, and therefore they will end up in the particular use column. So that is basically it. Like, there's nothing complex going on here, we can just do that. Next we have a gen. Okay, so yeah, gen. Now use is also called def. Oh sorry, no, I think I mixed the definitions up. No. Gen, yeah, let's just call it gen and move on. I think there's a def and a kill kind of a thing going on, but we'll come back to that later. I think we'll just continue for now, because I don't want to confuse myself with the definition, because otherwise it's going to get messy. So anyways, let me erase the markings that I've just made here to explain the idea. Okay, now for the gen, basically the point is we are looking at what is being generated in this particular block, and this is very simple. You just copy paste the entire LHS, right? So P, S, U are the ones in the first block that are being created, so they just end up here. In the second block it's just V, in the third block it's Q, and in the fourth block it's Q again, so no issues there at all. Okay, so we move. There was nothing to do here. Alright then, awesome. Now everything else from this point and forward is basically algorithmic. There is nothing much to do. Now generally what they'll do is they'll first make the in and the out column, but I'm telling you that the use column itself is the first the first sort of in column in a sense. So we'll start with the out one. Generally would write in and then copy the values of use within it and then do all that, because here's the idea. When you write in, I'll write it here. So in is basically equal to wait, it's probably better to write it somewhere else, maybe in the bottom somewhere. So in basically is equal to, so you basically have to do out minus gen union with I think it was use, right? That is how you're supposed to do it. And then out is in fact equal to the union of in of the successors. Basically that is how it is supposed to happen, and there is no need to go over the math like this kind of a formulation. We'll just see how it happens mechanically, and we'll go over it, we'll finish it off. It's pretty easy. So for the out, the basic idea is, so look at the first block, right? So we're making it for the first block right now. So for the first block, look at how many successors it has. It has 2 successors, 2 and 3. Now what we say is, okay, so what are the various things, or what are the various variables rather, that are going out of the first block? You don't have to do rocket science for this. You literally have to just look at the use, because think about it, right? What does the use column really mean? The use column really means that for this particular block 1, it is using QRV variables. Now where did the QRV variables come from? God did not create them. Someone in the program already wrote some instructions which created the values for Q, R and V, which were passed into this particular block. That is why it's called use. And then you have the column called gen, which basically represents that, okay, P, S and U were in fact created within block 1. So block 1 manufactured this, right? That is basically the idea. So that is why what we say is, okay, so when you're looking at out, you look at whatever the use or the in of the successors of this particular block are. So what that means is that if you look at block 1, the successors are 2 and 3. Okay, what are the in of the successors? So they are R, U and S. So we just write that R, U and S. That is basically it. There is nothing else going on here. It's very easy. For the second block, what is the successor? Is block 4. Now what does block 4 actually use? What is in its in? V and R. So we write V and R. That's about it. Block 3, what is its successor? Block 4. So again V and R, the same nonsense comes here as well. Now when we look at block 4, now be careful here. Block 4 does not just vanish, it in fact loops back to block 1. So block 4 is in fact feeding values to block 1, which is very amazing. So what do we say? That okay, so whatever values that block 1 is using is in fact coming from block 4. So that is why we say that what has to come out of block 4 so that block 1 can use it? Q, R and V. I mean, that makes sense, right? Like it's not going to like come out of thin air. Of course someone has to create it, and that creation job is of course of block 4. Now this is where the game begins. Now what you have to do is you have to keep going and basically make in and out again and again until things basically stabilize. Now how will they stabilize? We'll look at it. It's not a complex thing. Now how do you calculate the in? It's very easy. So what you do is you take out and gen. Just give me a second. Yeah, I think by the way, I just realized what I've done here. Gen is in fact called def as well, and the use is called I think no, I'm messing it up. I'll just use the regular definitions because otherwise I'm tripping myself up, which I don't want to happen. So let's call this what was it again? It was def, right? I'll just call it def instead of gen because it's throwing me off when I look at it. Alright, so when we look at in, what has to happen? We have to basically look at whatever the out is, and then we have to subtract whatever the def is from that. So basically it's a set operation, right? So what that is basically, again, see, out minus gen, or well, def, both are the same, that doesn't matter. Okay, so if we do that, rus minus psu, right? So s and u will get cancelled and you'll basically be left with r, and then you have to union with the u's, or basically the in one, right? So you'll get r, v and q. So q, r, v is the in2. Then vr minus v, which is basically r, union with ru will basically become ur. Amazing. Vr, yes, vr minus q is vr. Vr union su is SUVR, easy. QRV minus q becomes RV. RV union RV is RV. There is nothing to do here. I hope it's V, because I have in fact sometimes misread U as V and V as U, and my handwriting does not help it, unfortunately. Alright, so let's look at the out2 now. Now the out2, again, it's very easy. So we have to again remember who the successor for what is. So the successor of block 1 is 2 and 3, right? So you basically have to look at the in and union these two guys and paste it here. That's basically it. So UR SUVR simply becomes SUVR, easy peasy. For the second one, the fourth block is the successor, so we'll simply copy paste RV RV. Third block is basically the same. For the fourth block, the first block is the successor, which is QRV, so we'll just copy paste that QRV. That's basically that. Okay, now one thing that I want to point out here is that they are asking us live, so which are live both at the statement in basic block. So it is asking which variables are live within the block itself, right? So in the block, that's why we are calling it in. If they said that which variables are sort of live while exiting the block, then out would be sort of more important, but this is basically it. Now this is a good time to take a second and look at the in 1 and in 2 and compare them. Has there been any change? And yes, there has been a change. So QVR is the same, RU is the same, but if you look at the third block's in list has actually expanded. So it was earlier SU, and now it is SUVR. So therefore it means that we still have a lot more work to do. So it is possible that even more variables are being needed somewhere. We'll find it out. So let's run the whole calculation again. It is extremely simple. There is sort of nothing crazy that we have to do here. So we'll take the out, okay, we'll take the out 2 and we'll subtract it from the def. We have to repeat the same process basically, SUVR minus PSU. So we'll get, I think, SV and QVR. So SV QR, I think that is basically what we'll get. Let's hope that is correct. S will not come actually. Yep, good. Yeah, okay, so S will not come, right? PSU, SU, VR, QVR. Yes, QVR. Okay, that's amazing. Now RV, right? So this is RV, and then there's a V here as well. So we have R union RU will give you RU. RV minus Q, right? So yeah, I do think that is RV. Yes, so RV minus Q will give us RV. RV union SU will give you SUVR. Amazing. Then if you look at this QRV minus Q will give you RV. RV union VR is basically RV. Now again compare in 2 and in 3. Okay, now what you'll notice is QVR is the same, UR is the same, SUVR, RV, which means now we have reached a stable state. You basically have to repeat this process until and unless you reach a stable state, which will happen after like around the third or fourth iteration. Just keep going. It's honestly very easy. It's a brain off procedure for the most part. You don't have to do much. Now all they are asking is which variables are live both in block 2 and in block 3. That is a pretty stupid question to ask, because look, you already have the answer here. So R, U intersection with SUVR. What is the answer? Well, like, I mean, you can probably just look at it and go R and U are the clear winners here, and therefore this C is the correct option. And that basically is the way to do this problem in a sort of algorithmic way, and I recommend this method. I think there is no need to push and learn the The other way is more involved and it is more fun, but it can in fact lead to a lot of careless errors. It has happened with me, that's why. But even then I'll still go over it and what the idea behind it is, now that we have understood what use, def, out, in and all that stuff is. So let's look at the variables. So they have said this is the second method now. So block 2 and block 3. So you look at block 2 and you look at block 3. What you will realize is that, okay, let me actually try to create some space if it is possible. I don't actually remember the tools. Maybe it is this. Whoops, not like that. Let me try again. Yes, there we go. I think that is probably better, and we'll turn that off. Whoops, finally. Okay, just a second, we can remove that now. Yes, now I have some space here. So now the idea is, okay, so block 2 and block 3, right? Consider this. So if you look at block 2, okay, if you look at block 2, what variables are alive? Now alive in the sense, what variables are actually being used inside here? Used, right? So use means like someone has to pass it, so some like ancestor has to give it. So that would be u and r, right? So you would say that for block 2, the variables that seem to be important or very much necessary at first glance is u and r. They are the live ones. Okay, these are the live variables. Okay, live. Now if you look at 3, what are the live variables here at the first glance? S and u, right? Because they are the ones that are creating the value. But now focus. So 2 is the ancestor for 4. That means that whatever variables this fourth block is using, second block is definitely providing it. It has to provide it. Don't look at the fact that, okay, 3 is also giving something. That does not matter. The point is that 2 is definitely providing whatever variables 4 is sort of using through it, right? 2 definitely has those variables, right? So they also have to be alive. They can't be killed off. Now what are those variables that are being used? V and R. Now notice V in fact is being created here in block 2. Therefore in block 2 V is not considered alive. Okay, V is not considered alive. It is in fact dead. It is a killed variable that is basically raised from the dead in a sense. Okay, so V is not considered and R is being passed along anyway. So okay, we basically have got this part correct. Now if you look at 3 and 4, notice what happens. So now forget the fact that, okay, 2 is giving something, no one cares about that. Look at 3 and look at 4 only. So 3 is actually giving S and U, but fourth block is actually using V and R, which means that the third block must in fact give it R and V. Okay, the third block must in fact give it R and V. Okay, we can go ahead and like do whatever looping nonsense it is. I think that does not matter, but at this point you are more than qualified to basically look at these two and from here perform the simple intersection and say that, okay, u r and u r appear in both of these. These are the live variables that both of them have, and therefore this is the option. This is also another way to do it. This way is good. I think it works, but it does in fact need quite a bit of work. And if they switch the problem into the dead ones or not dead ones, sorry, if they switch the problem to ask which variables are sort of the ones that are live when exiting the block, then it might get a bit tricky, maybe, I'm not sure. But that is basically it. It's a pretty simple type of question that if you cannot solve, or if I cannot solve, because this is for me, not for you, if I cannot solve it using this particular intuitive method, which is just basically looking at the problem with my eyes open, then of course the algorithmic way is of course alive. And of course you will notice here something very interesting, which is that this method that I just used right now, where I immediately sort of have the live variables immediately for block 2 and 3, it took me like 3 iterations to actually get that using the table method. So that is definitely something to know. But again, intuition comes at a cost. Sometimes you will not see a fast one coming, and that is the reason why the table method is a very good backup, and in fact it is the most rigorous and best way. We'll do another one. I'll do another problem where it is in fact asking for the variables that are alive when exiting the block. So yeah, until then, I guess, yeah, I mean, I'm going to record it right now. Alright then.